Hello everyone, my name is Hesham, and I'm here today to talk to you about a particular problem we've been working on, and that's on mobile game performance measurements. We see this as being a sort of challenging area because there's many aspects that are a problem in mobile that don't necessarily occur when you're talking about the more traditional platforms like PC and console. Just like to give a quick overview to start things off with. We'll go through some trends and observations that we see in mobile gaming. Then ask ourselves, what is mobile gaming performance? What's our particular take on this? After that, I'll talk a bit about a specific problem we have in Samsung and how these methods that we're sort of looking into help us resolve that problem. And then a brief mention about some future work. So some trends and observations to kick things off with. So here's a nice infographic produced by Newzoo. It's from a 2019 report on the global gaming market. And we see that 45% of gaming revenue is in mobile. That may surprise some of you if you're thinking about the traditional platforms like console and PC. It's growing and it's sort of gaining on that area and overtaking. And that accounts for $68 billion of revenue. Very staggering. If we take a flip on that and we say, okay, how is gaming in terms of mobile phone usage? We can see that we get a similar sort of story. So this is based on a study from App Annie, and it shows sort of mobile game usage on the mobile platform compared to other types of apps. And you can see that gaming plays a significant role in how people are using their phones now, in terms of installs, usage, and revenue. If we take a look at sort of how gaming is seen on phones these days, so we know gaming's existed on phones since sort of the inception, particularly with smartphones. But back then, it was maybe simple puzzle games, very simplistic stuff, and significantly different from console and PC. But we're starting to see some changes. So this is a sort of simple Google Trends output showing sort of relative search terms. And in this case, it's for best gaming phone. And pretty clearly, we can see in the past couple of years, there's been an increase in the number of searches for best gaming phone. We think this indicates there's a significant change in people's perception of what their phones are for. They're buying phones specifically for their gaming capability rather than just as like a side use. And what's driving this? Here's a list, top 10 list of popular games, mobile games, and we can make a few sort of observations on this. So key ones being that there's a lot of PC ports or clones that are very popular these days. Popular ones like PUBG, Minecraft, etc. And these are games that have been developed for a relatively unconstrained device, so PC or console, where concerns about thermals and battery, they're not really issues, to a much lesser degree than mobile. And developers want to port those experiences onto mobile, where it's heavily constrained, but have as similar performance as possible. So this is driving this sort of trend into gaming-specific phones, where they're trying to offer the same experience as they would do on traditional platforms, but in this much smaller, constrained form factor. So say you look for what the best gaming phone is. What are you typically met with? Usually you see a bunch of forums, discussions, tech reviews that try and compare these phones against each other. And they use a lot of terminology like superb battery life, improved cooling, lots of screen space. And these are very sort of descriptive terms, and it leaves a lot to the user, the consumer, to work through this and work out, okay, which one actually is the best phone. And when they do mention more performance-related metrics, it's usually very simplistic. So they'd say things like smooth 60 FPS or some very sort of abstract measure that's supposed to relate to how it performs. And a lot of the times, they also give device specs. And for a lot of consumers, they don't know what that means, really. So we think these current approaches don't really capture what we're trying to achieve, which is what phones run our games the best. So I've alluded to the fact that performance matters for gaming-specific phones, but does performance actually matter to the end users? Here's a study we did based on a lot of the data we have at Samsung. So we've got a lot of performance data from real users. And we looked at 90,000 users who played Fortnite as their first sort of play session. So we were seeing, does performance impact behavior? And in this case, behavior was engagement. So we looked at simple single session churn. So a user played a game, and did they subsequently play another game, like a second session? And we related that to a particular measure of performance, in this case, smoothness. So the smoothness of the session in terms of the frame rate. And we saw sort of a clear inflection here that above sort of 80% smoothness, we get higher attention. You know, it's not massive, but it is significant. So clearly, you know, performance matters to gamers. So just to sort of give you the key takeaways for this first bit, we know that mobile is important in gaming. Gaming is important in mobile. And you know, in terms of mobile gaming, performance actually matters. So performance matters, but exactly what do we mean by performance? I've given a simple measure already, but really that's not the full story. When trying to answer this question internally, we sort of took a slightly different spin on it, and we thought, what are the factors controlled or influenced by the phone that affect the user's gaming experience? And we've broken it down to some loose categories. So the first one, and most common quoted, is FPS. We've termed it visual smoothness. But what do we mean by this? Usually when you think about performance of games, they quote these FPS measures. And you hear numbers like 30 FPS, 60 FPS, and more recently, 90 and 120 FPS. And these sort of relate to measures like the minimum standard that people are aiming for, a generally accepted good standard. And with the recent trend in pro games and competitive games, 90 and 120 FPS being a new standard. But really, these are targets. These aren't actual measures themselves. If we look at some actual data, what do we see? So this is a trace for FPS through the course of a gaming session. And you can see, so it's with this blue line. And it's very hard to say this is a single value, or there's some good representative value for this. We can see at the start of the session, maybe you can argue you've got a smooth 60 FPS, but then very quickly it starts to sort of fluctuate rapidly. And if we try and take some summary statistics from this, you could say a median value captures everything that you need, but really that's probably not good enough. You can see there's a significant sluggish period, and there's also this very significant drop in FPS right at the end. And these are just values, but really what we'd want is to know the relative impact of all of these on the gaming experience. Going beyond just smoothness, what else do we think is important? The quality of the graphics is another significant area that we think is important and often not captured in any robust way. So here's an example. This is a PUBG session, and you can see a low quality graphics setting and a premium quality setting. And there's a number of factors that contribute to how good a particular scene looks. Here are a number, so things like texture quality, dynamic range, and resolution. And these interplay with the other measures, so things like smoothness. There's always some sort of trade-off between how smooth the game is and how good it looks. In a lot of tech articles and videos, they do it at a very high level. They say, you know, it looks good or it doesn't look good. But we think having a more robust way, a more quantitative way of measuring this, it would be valuable. Beyond this, other factors are important. Swiftness and responsiveness. So typically gamers don't like to wait. And we sort of see this in two different areas. So one is loading, particularly with mobile games and gaming on the go, and very short sessions that people play. They don't want to be waiting to actually get into the game. Here's some sort of recommended target by Facebook's development guide, and they say the initial loading shouldn't be more than 5 seconds. Obviously, this doesn't apply to every single game. Different games you've got different expectations for how long it should take to load. But clearly, that's an important consideration when you're talking about the performance of a device. If it loads games faster, it's better in some ways. Similarly, you can think about things like the control scheme, particularly with the recent boom in competitive games, where there's a lot of these fast-paced first-person shooters and similar types of games. The actual responsiveness of the touch latency is another important factor. Some studies have shown that people can reliably perceive touch latencies as low as 5 to 10 milliseconds. So that's an order of magnitude below what most games operate at. So clearly there's room to sort of measure relative performance. And so far, the metrics I've sort of listed have been related to aspects actually within the game. But there's other factors of the phone particularly that we think are important to the overall gaming experience that should be taken into account. And two of these are the temperature and the battery. So if you're playing a gaming session and your phone's starting to overheat, or you notice it's draining quite fast, it's not a good experience. So we think those are things that need to be captured as well in a sort of holistic measure. So to wrap up this bit, we think mobile gaming is more than just FPS. We need to consider the other measures and try and come up with a way of sort of saying how good a device is, taking everything into account, really. So I'm just going to sort of dive into a little problem we have internally, not necessarily a little problem, but a problem we have at Samsung and the approach we've taken to try and solve it. So our problem is we've got a load of devices. So there's a massive amount of devices we produce. And along with that, there's a lot of types of games out there. And we really want to know how well our devices run every single game. But you can sort of fathom it's not realistic to test every single device against every single game. So our sort of task was to come up with a reasonable middle ground. Can we come up with ways of differentiating our devices in terms of their gaming performance that's as useful as possible? So not just one single measure that says this device is the best at gaming, but say it's the best at gaming in this particular situation or for this subset of games. And with our approach, we tried to keep to a few sort of set principles. So we wanted it to be as robust as possible. We're play testing sessions. There's a lot of randomness involved in that. So having a structured approach that gives you sort of similar output each time you test it. Have it be generalized. As I mentioned, there's many games and many devices. Having a set methodology that is applicable to all of them is one of the goals. To have it be comprehensive, we want to capture every single component that matters in the gaming experience. And experience-driven, so taking a user's perspective, what's important to the user? If a performance change doesn't really affect the enjoyment of a game, then it's not really worth capturing in some sense. So with this, we sort of came up with this generalized framework. So we followed the aforementioned sort of areas that I went through. So visual smoothness, graphics, battery power, temperature, and swiftness and responsiveness. And for each of them, you can see they're built up of some components, which are more objective. They're just statistics, aggregate statistics from a particular gaming session. And from that, we aggregate them into these slightly more subjective, experience-driven measures. And further than that, we can combine them into a single gaming score and say, this device gets this score for gaming. But really the challenge is in how do we get from this layer and work up to this single value? And for that, we need appropriate mapping. And our approach on this was to try and take a user-based approach and look at types of games and types of gamers. And can we come up with models that reflect their wants and relative expectations for performance and move up this layer and come up with a representative score? So we came up with a methodology, came up with some ways of measuring various aspects for devices. and we trialed it on some of the recent flagship devices. So you can see here a set of devices. So these are flagships from the past 2 years, and it shows the overall performance score. And we measured them under two set of criteria, so a competitive gaming criteria and a casual gaming criteria. And I've given some loose descriptors about how we characterized each of them. So a competitive gamer expecting a smooth, responsive experience with lesser concerns about battery life. Whereas a casual gamer, maybe they care more about their battery, but they're playing simple games where you don't really need to have as smooth a game or as good-looking a game as possible. And we see some interesting things. So probably one striking thing is that the best performing phone in a competitive sense is not the best performing one in a casual sense. Obviously, you'd expect them to correlate to a heavy degree, but the fact that there's some reversals and changes in ordering gives us that added benefit of saying, okay, under these circumstances, this is our best phone, and this is our worst phone, and sort of vice versa. So we developed this, we've sort of tested it in some cases, and we want to take this further. But already we're seeing it potentially being valuable to many different players in the industry. So from game developers, device manufacturers like us, and other device manufacturers, as well as media. And they all come together under one sort of overall goal, which is to deliver the best end user experience, whether directly or indirectly. So I'd just like to finish by mentioning a few points about our future work. So the next steps. Just to reiterate the goal, we want performance measures which best map to the user experience, what's important to them, and what's key in terms of mobile gaming performance. And we can sort of break this down into two challenges. So how do we best describe our games, and how do we best describe our gamers? We want them to sit in some common subspace where expectations on the game, so are they fast-paced games, are they slow-paced, do they have detailed, realistic graphics or very simple graphics? And then expectations of different gamers. Try and match those together and come up with reasonable groups. You know, it's not a hard like constrained problem. It's very sort of loose. So those are our two main challenges, and our approach at sort of tackling this is to conduct large-scale user surveys, get opinions on relative importance of some of these categories, and conduct perceptual studies. So can you look at things like FPS? Can you say for fast-paced first-person shooters, you need to be at least 58 FPS to have a satisfactory experience? Those are the sorts of studies that we're looking into. And beyond this, we want to establish good practice with other industry partners. As I said, a lot of the stuff is loose, so we need to come together and agree on some set of standards that we can all agree on and say this is more representative. So if you want to know more about this, we've sort of produced this white paper. It's in the process of being published, but if you need a copy, you can email me and I'll send you a copy. So this is actually the last of a set of gaming sessions, gaming-specific sessions. So I hope you've enjoyed them all and learned something valuable and maybe seen some useful tools that you could make use of. Thank you, and if you've got any questions, just email me. And bam, lucky draw. Okay. So the winner is 174. Yeah. Yeah. Hey, you.
Thanks.
Congratulations.
Thank you.
Sorry.